Welcome to PdMA Corporation, home of the MC Emacs. I'd like to thank you for joining us as we continue along in our presentation series. Once again, we're happy to have Mr. Noah Bethel, the Vice President of Product Development.
Hello from sunny Tampa, Florida.
And myself, Todd Gunderson, the Vice President of Sales and Marketing at PdMA Corporation. And we're going to bring you Some Like It Hot, but Not This Hot.
It's an appropriate conversation when discussing installation of electric motors.
Yeah. So talk to us a little bit about when ratings are exceeded, when your temperature ratings are exceeded in a motor.
Well, one of the major variables in design criteria of electric motors is how much airflow or cooling is required to prevent the overheating. Obviously, the hotter a motor gets, the more likely the insulation will break down, and if the insulation breaks down, then the current that's supposed to be flowing through the copper windings ends up flowing to ground or to other windings.
Yeah. So let's move into this case study, and here's our motor in question.
It's a good-looking motor.
125 horsepower, so it's a decent-sized DC application. We have an undersized blower. You talked about that on the first slide.
Yeah, no, that's important. And in fact, with DC, there's a lot of current, there's a lot of heat, and obviously by original design, you would think that the designers built in enough airflow to support the heat removal. But a lot of times, either in a bad engineering design or more than likely a rebuild, the airflow is modified unknowingly, and as a result, excess heat.
Excess heat can destroy. So here's a nice picture from a thermographic look. We have two pictures here. One's with the undersized blower, one's with the normal sized blower. And here's very important, have multiple technologies. We're very much for that at PdMA, we're pro multiple technology approach to determining motor problems. We see the normal sized blower here at a spot temperature of 106 degrees Fahrenheit. We see the undersized blower. And what is this showing us, Noah?
It's showing the money just disappearing. You know, it's interesting because in motor testing, a lot of times you hear us talk about, the red is bad when it comes to an alarm. But in infrared, for you thermographers out there, white is bad, right? And so the motor on the left obviously has a much higher temperature. We're talking almost 40 degrees above the normal design. And again, this is on the external side, so it's very warm.
So we're looking at the skin temperature. So internally, it's much hotter than this.
You can expect a 40 to 60 degree rise even above that, and whatever the motor's designed, a lot of internal heat.
Right. So we're going to take a look at just hard data now. This is a quick review of some of the data points that were taken with our technology, and as you can see here, comparison between the normal motor and the motor with the smaller blower, we have significant differences in our capacitance, our resistance, and our inductance.
Yeah, this jumps out like a sore thumb to anyone who's ever followed this information. And one thing that I like to point out here is the fact that the word normal lives with multiple motors. And the beauty of a DC motor troubleshooting situation is often, if not every time, there are comparison motors to look at. And so this company knows what is considered normal through the testing of multiple motors of the same design. Now, unfortunately, in this situation, this motor is not normal.
Yeah, and one other thing that jumps out at you is resistance to ground was fine.
This is the scary part of this. You send your technicians out with a magometer to verify the health of this motor, you completely miss it. And this happens all the time, where you saw that the inductance values dropped from huge values down to like 300, a massive drop in inductance, resistance, and capacitance.
Right, so it went from 3,000 millihenries down to 300. It went from 80 ohms down to something 60 ohms.
We have definitely lost some windings here.
Right. So what's always nice is when you can get a picture to put the data in place.
That really solidifies what's going on internally, because rather than having all those strands individually conducting current, now we're shorting between these conductors, and current's taking the less optimal path.
And you can see just the varnish itself. Class F insulation, once you get above 155 degrees Celsius, you're starting to destroy that insulation.
Dark, cracked, loose, and brittle insulation this is either going to burn up turn to turn or eventually go to ground and might even cause a fire.
Right. So some lessons learned from this undersized blower. Motors with mounted blowers need to be cleaned and inspected.
Yes, a fan that has a dirty filter, no air moving, doesn't do much fanning.
You're overworking that motor, aren't you?
Indeed.
Motors with shaft-mounted fan blades should be inspected and cleaned on a regular basis. Now, in our technology, we also have what we call demodulation, where we can kind of look at the mechanical fan blades through the current spectrum, right?
It is a very nice correlation and crossover from electrical to mechanical. It's a great asset to the motor testing, which gives just a nice insight into the mechanical world of fans, blades, pumps, vanes, belts, you name it. It's just a good correlating indicator.
Electric motors need to be included in IR scanning routes, as well as MCA scanning routes.
True. When you're running around with your cameras, even if it's just primarily a qualitative indicator, it's an external look. But sometimes just knowing something is different on the external side allows a flag to go up. Then you go get your MCE or your Emax tester, and you start looking on the inside of that motor to learn some more quantitative information.
Right. And inductance, as we saw in our data, is very sensitive to any type of turn shorts that are going on in that motor.
Many of you have been through courses where we talk about the inductance calculation, and turns are a squared variable within that calculation. So absolutely, you start to lose turns, inductance changes greatly.
Right. And an old rule of thumb states for every 10 degrees Celsius in operating temperature overrated, we're going to cut that motor life in half.
Yeah, I think we might be down to the half of the half on this one.
We're half of the half of the half. Well, this brings us to the end of our case study, and always we'd like to thank you for your time and consideration. If you have any questions, please feel free to contact us at the number provided on the screen, or check out our website at www.pdma.com. And as always, stay safe out there, and thank you.